Hey folks, let's take a look at example 9. Now, we've got two fractions, they've got different denominators, so we'll go find an LCD in a moment so we can get common denominators. But I want our spidey senses to go off. That subtraction symbol, we got to be careful when we subtract, especially after we get our least common denominators. So if I look at my fractions here, I've got a denominator of x plus 5. This is essentially a binomial, right, raised to the first power, and I've got a different binomial down here raised to the first power. So I have two factors that are each raised to the first power. So ultimately my LCD here is just x minus 5x, x plus 5, x minus 3. Okay, so that's where I'm going to start. And I'm going to erase all my little shenanigans here just so it looks a little cleaner. And now what I'm going to do is I'm going to multiply each fraction by the version of 1 that they need, so that we can get our denominators over to our common denominators. So what I mean by that is I'm going to start with my first fraction of x over x plus 5. All right, if I look at my denominator here, in comparison to my least common denominator, I'm missing this x minus 3. So what I'm going to do is I'm going to multiply this fraction by x minus 3 over x minus 3. And just so we're protecting our binomials, I'm going to put parentheses around that. Okay. Now I'm going to put the subtraction sign, and when I look at my second fraction, the denominator is x minus 3. If we compare that to the LCD, you can see I'm missing a factor of x plus 5. So I'm going to take this fraction of 2 over x minus 3, and I'm going to multiply it by x plus 5 over x plus 5. And just so that I'm careful, I'm going to protect those binomials so that we remember they are binomials, all right? And so now that I have a common denominator, right, if I just clean this up a little bit, right, I have x minus 3 here, and then I have x plus 5, x minus 3. Right? And this is an intermediate step. You don't actually need it. I have 2 times x plus 5 over essentially x plus 5, x minus 3. All right, so you can see I've got now two fractions with common denominators, but I really need to be careful and send this 2 to this entire numerator. I'm sorry, not the 2. Well, the 2 also, but I need to subtract this entire numerator. So what I'm going to do is I'm going to rewrite this. Actually, let me go in the order I have been. Because I've got common denominators, I'm going to keep my common denominator, right? And then I'm going to take my numerator of x minus 3, and I'm going to subtract 2, x plus 5, right? And then it's a matter of let's simplify the numerator, see if anything cancels, right? And then I also will need to see if anything from the numerator still cancels with the denominator. There's a bunch of algebra we're going to do at this point. So as I start to simplify this, I'm going to actually move this over here just so I have a little bit more space. All right, x times x is x squared. X times negative 3 minus 3x. All right, negative 2 times x is negative 2x. And then please remember to distribute that negative 2 to that positive 5, ultimately for a negative 10. Right, and then I keep x plus 5, x minus 3. All right, so we're just going to keep on simplifying that numerator. I can see I have some like terms here. And so this is not ultimately, but the next step, what do I have? X squared minus 5x minus 10, and then I'm going to go ahead and put that over x plus 5, x minus 3. All right, and then I have to think, do I have two numbers that could multiply to 10 but add up to 5? And if we break down 10, it's essentially 10 and 1 or 5 and 2, right? And so if I was going to try 10 and 1, the most those could add to are 11, right? 10 plus 1 would be 11, or 10 minus 1 would be 9. So that's not going to get me a negative 5. Here, 5 plus 2 could be a 7, or 5 minus 2 could be 3. That's not going to get the 5 here. So this quadratic expression on the numerator is prime, and I can't cancel this binomial with a trinomial or this binomial with a trinomial. So I'm essentially done with this problem. All right, thanks so much. Bye.